Lesson 9-7, Similarity Transformations. Students will be able to identify similarity transformations and verify properties of similarity after watching this video. Drawing transformations. The black triangle, DEF, has vertices 2, 0, 1, 4, and 4, 2. What is the image of the triangle when you apply the composition, a dilation 1.5 following a reflection over the y-axis? So this question has the answer done for us. So I'm going to go to a different slide. You do not have this in your packet. So what we're going to do is we're going to take our original figure. So I found the coordinates of our original. So there's our original. Forward 2, up 0, forward 1, up 4, forward 4, up 2. Then, because in the directions it says following, we have to do our reflection first and our dilation second. So, if we do our reflection, we remember from our note packet that when we reflect over the y-axis, we negate the x. So that becomes negative x, positive y. So I'm just going to negate everything in the x column. So my 2 is going to become negative 2. My 1 is going to become negative 1. My 4 is negative 4. And the 0, 4, and 2 will all stay exactly the same. Then I'm going to apply my dilation. So like you learned in lesson 9-6, we're just going to multiply everything by 1.5. Okay, so if we go back to our reflection, if we reflect over the y-axis, this is where our shape goes, and it becomes D prime, E prime, and F prime. Now we need to dilate. So like I said, we're going to multiply those numbers by 1.5 on all of them. Then what that's going to do is it's going to enlarge our picture. So here is the picture of the answer. So we started with the black, and then our reflection over the y-axis went to the red, and then our dilation made it bigger and turned it into the blue. And this would be the coordinates of those endpoints. Let's try another one. Triangle LMN has vertices that are given. Suppose the triangle is translated 4 units to the right and 2 units up. So to me that looks like this. 4 units to the right and 2 up. And then we're going to dilate by a scale factor of 0.5, with the center of dilation being the origin. Sketch the resulting image of the composition of the transformation. Well, when I take my triangle, I'm going to take my triangle, and I'm going to slide it forward 4, and up 2. Okay, so that's where my translation takes me. My dilation makes my shape smaller, so I can't actually slide this to where it needs to go. So what I did was, I wrote down what the coordinates of my translation was. And you could have done it without using the graph, because all you're doing is adding 4 to the first coordinate, adding 2 to the second coordinate. But now with our dilation, we need to take those numbers and we need to multiply them by a half. So the 0 stays the same, 4 becomes 2, 1 becomes a half, negative 1 becomes negative a half, and so on. So now if we plot those points, and then I went back and put the markings on my triangles. Remember, you can pause the video at any time if you need. On the next slide, it says, what is the composition of rigid motions and a dilation that maps triangle RST onto PYZ? So we're going to start with this triangle here. So what I'm going to do is find the coordinates of that triangle. So it looks like 1, 1. S is at forward 1, up 3, and T is forward 3, up 1. So there is our original. And then we're going to do something to that triangle to make it turn on to the other one. So I think what we should do next is maybe look at the coordinates of our answer. So R corresponds to P, S corresponds to Y, and Z corresponds to T. So maybe I'm going to write those on here. So our R becomes P, our S becomes Y, and our T becomes Z. So I just wrote down double prime because that is the second image that happens. So now if we compare our original to the end, we can kind of see what's going to happen. We know it says in the directions that we have to dilate, so we have to multiply. So just looking at that, 1, 1 becomes negative 2, negative 2. 1, 3 becomes negative 2, negative 6. So I see 1 times 2 would be 2, and 3 times 2 would be 6, but then they all become negative. So I'm thinking in my head, maybe my dilation is doubling, and then I have to do something that makes the x negative and just the y negative, because then these original points would look like these points here. So I think we can do that. If we look at our picture, how would we get this original to turn over here? And that's where our rotation is going to come in. So I believe we are going to rotate this 180 degrees. So I think I wrote that wrong. So I'm going to do a lowercase r, 180 degrees. So if I do that, rotation of 180 degrees, our rule is absolutely this what we had written down right here. So we are going to negate the x and negate the y on each of those points. So 1, 1 is going to become negative 1, negative 1. 1, 3 is going to become negative 1, negative 3. So it's looking like what we're going to do is we are going to do a dilation first. Of 2. We're going to dilate 2. We're going to double. So that should be a 2 here. And then we're going to, before that, or after that, do a rotation of 180 degrees. So this would be our answer. A rotation 180 degrees following a dilation of 2. So if we took our green shape and we rotated it 180, it would end up here. And our doubling, this side is 2, so then this side here is 4. And then you can kind of see how that is going to dilate about the origin. Here's the next slide. What is the composition of rigid motions and the dilation that maps the small trapezoid to the big trapezoid? So what I did first is I went to our first trapezoid, and I wrote down the coordinates of the smaller one. Okay, so the smaller one is the first one. If you need to pause to write those down, please do that. So we're going to do two things, and we know one of them is going to be a dilation. So you have to figure out what the other thing is. So just looking at our trapezoid, I'm kind of noticing that we have a regular trapezoid and not an isosceles. So this side looks to be a little bit longer than the other side. So on the smaller trapezoid, I think this one is also the smaller one. So I'm going to assume that this side and this side are going to correspond, top to top, bottom to bottom. So it looks like we have to do a reflection. So if I reflect this, it looks like I'm going to reflect it over the y-axis. So if I reflect over the y, I negate the x. The next thing that I did is I wrote down the coordinates of our final image. So B, A, D, C, as it was stated up in the directions. So now we're going from the green to that, and we're trying to figure out what our dilation is. So it's looking like our dilation, how does 1 become 2? How does 3 become 6? 4 becomes 8. So it looks like we are going to double. So I think we've figured out what we need to figure out. So we are saying that we reflected over the y-axis, and then our dilation is going to be doubling. So I think we reflected over y first, and then we dilated. So we can write this as capital R-Y in the back, and then D of 2. So a dilation of 2 following a reflection over y. Similar figures. Two figures are similar if and only if there is a similarity transformation that maps one figure onto the other. So is there a similarity transformation that maps a triangle onto the triangle? If so, identify the similarity transformation and write a similarity statement. So previously we have learned what the similarity theorems are. We have SSS similarity, AA similarity, and SAS similarity. So looking at this, our definition of similarity is that angles are congruent and sides are proportionate. So we're trying to find our matches. So I think 10 is the smallest. So 10 is going to match up with 12. 12 over here is going to match up with the 16. And the 16 here is going to match with the 20. So now we kind of know what corresponds to what. So we can write our proportionality statement. So if I do that, I get 10 over 12, 12 over 16, 16 over 20. And checking to see if those fractions are equal, I'm getting 5 over 6 here. 5 does not go into 16 or 12, so no, this is not going to work. So this would be false. This one will not follow any of those similarity theorems, because none of the sides are proportionate. In the next example, finding similarity transformations, is there a similarity transformation that maps triangle PAQ onto TNO? If so, identify the transformation and write a similarity statement. Well, our choices again were SSS, AA, and SAS similarity. So on this one, I think we have pink to pink, yellow to yellow, so this would be by AA. So I'm going to say yes. So then triangle PAQ, so pink, yellow, orange, is similar to TNO. So that's our similarity statement. And it says find the transformation that maps it. We're not actually going to do a lot of that, but it looks like this would be a rotation of 60 degrees following a dilation of 1.5. And I'm going to leave that one alone because we're not going to rotate without having a coordinate plane on there. And this last one is a repeat from 2 slides ago. So this concludes my lesson on lesson 9-7. Make sure you keep your cheat sheets with all of your transformation rules.